April 2023, New Britain Island. An industrial bulldozer is carving a logging road through dense jungle terrain. The operator is not looking for aviation history. He is clearing a path for heavy timber transport. The blade cuts into the side of a mountain and hits a buried obstruction. It is not rock, it is aluminum. The heavy steel blade shears through the soil and rips an 11-foot 7-inch diameter propeller free from its reduction gear. It flips a radial engine out of the earth and exposes it to the sunlight for the first time since the war. This is not a coordinated recovery operation. It is an accidental collision between modern industry and a lost war machine. The violence of the discovery creates an immediate crisis for forensic investigators. The site has been disturbed and the crash context has been rewritten by earth-moving equipment. But the same collision also cracks a mystery sealed since 1942. The aircraft is a Boeing B-17 F Flying Fortress. It was assigned to the 19th Bombardment Group of the 5th Air Force. It failed to return from a night mission with 9 crew members on board. For 8 decades, the location of the crash was unknown. There were no confirmed witnesses. There was no recorded radio distress call. There was only a gap in the records where a heavy bomber used to be. The objective now is strictly procedural: reach the site and secure positive identification before the environment or the logging schedule erases the evidence. There are hundreds of aircraft still missing across Papua New Guinea. Finding aluminum is not enough. The team has one job: prove which specific airframe this is by matching a serial number to a missing crew report. The operating environment is hostile to preservation. The site is located on a steep gradient inland from the coast. The soil is wet and reactive. The jungle canopy is thick enough to block satellite observation. The only reason we know this wreckage exists is because the logging road cut right through the center of the debris field. This creates a paradox. The road revealed the wreck, but the road also threatens to destroy it. Access is the first constraint. Shortly after the bulldozer exposed the engines, a heavy tropical storm washed out the newly cut road. The mud collapsed. The route became impassable for vehicles. It sounds like a minor detail, but it changes the security dynamic. The washout becomes an unintentional barrier. It keeps looters and casual scavengers from driving straight to the site. The same mud that blocks the survey team also protects the evidence. The team must now move on foot. They are racing against the chemical decay of the metal and the operational schedule of the logging company. They need to document the wreckage in situ. They need to separate the damage caused by the 1942 impact from the damage caused by the 2023 bulldozer blade. This distinction is critical. If the propeller was sheared off during the crash, it tells us about the energy state at impact. If it was sheared off by the bulldozer, it is just site contamination. The investigators must read the metal surfaces to understand the timeline of destruction. The primary target for the survey is identity. A B-17F is a complex machine with thousands of serialized components. But after 80 years of immersion in a rainforest, most of the painted markings on the exterior skin are gone. The tail number is likely disintegrated or buried. The nose art is gone. The team must look deeper into the mechanical structure to find the proof they need. We know the machine is exposed. We know it was a heavy bomber lost in 1942. We know 9 men were on board when it left the runway. But we do not yet know if the violence of its discovery destroyed the specific markings required to prove its identity to the world. The rainforest of New Britain is not a static landscape. It is an active biological system that consumes foreign objects. When a 65,000-pound aluminum aircraft hits this terrain, it triggers a familiar reality of rainforest loss: rapid overgrowth, burial, and concealment. This is a process where the vegetation does not just cover the wreckage, but integrates with it. Vines lash structures to the earth, roots grow through aluminum ribs, and bulkhead lightning holes. Within a few years of an impact, the canopy can close overhead. It becomes a high ceiling of leaves that dims the light at ground level and makes a crash site hard to spot from the air. This mechanism explains the silence. For 80 years, search aircraft and satellites passed over this coordinate and saw nothing but unbroken green. The occlusion boundary erases the optical signature of the loss. It turns a debris field into a geological layer. This is why the discovery took a bulldozer. The wreckage was not sitting cleanly on the surface. It had been swallowed by the hillside. To understand the condition of the airframe, we have to reconstruct the energy state of the loss on September 15, 1942. This was an early war flying fortress assigned to the 5th Air Force, flying a night mission against targets in Rabaul. The crew of 9 under Captain Robert L. Williams did not send a distress call. They did not bail out. The evidence on the ground is consistent with a high-speed collision with rising terrain. The aircraft does not appear to have disintegrated at altitude. It seems to have struck the slope while still largely intact. The physics of that impact are unforgiving. The kinetic energy of a heavy bomber at speed cannot be absorbed by an airframe built of aluminum and rivets. When the aluminum skin hits the hardwood forest, the structure shreds, the wings separate, the fuselage buckles and tears open. The debris field is scattered across the gradient. Heavy components like the radial engines and landing gear carried their momentum forward and dug into the soil. Lighter components like the tail surfaces and stabilizer skins were caught in the trees or shattered into fragments. This is not a neat landing. It is a debris fan defined by velocity and slope. Among the scattered aluminum, there is a specific technical detail that marks the vintage of this machine. The nose section debris contains fragments of the bombardier's glazing. On the B-17F model, the nose cone moved toward a molded, one-piece plexiglass form with lighter framing than the earlier E models. That detail is consistent with an early war F-series airframe. It confirms we are looking at an early war machine. Recovering this aircraft is not currently an engineering option. The site is too remote. The terrain is too steep. But the primary constraint is not logistics. It is the condition of the structure itself. The crash forces compromise the integrity of every frame and spar. The 80 years of corrosion in a wet jungle environment dissolved the magnesium components and weakened the aluminum alloy. You cannot lift this airframe. It has no structural continuity. The environment acted as a tomb. It hid the aircraft from the enemy in 1942 and from search teams for the next 8 decades. But while the jungle protected the site from human interference, it also trapped the evidence needed to prove who was on board. We know the mechanics of the crash, we know the physics that tore the plane apart, but the jungle also hid the small, crucial details that separate one B-17 from another. And the proof of who was on board, 41-24427. This sequence of 7 digits is the defining constraint of the entire operation. In aviation archaeology, the identification of a wreck is often assumed to come from the large painted numbers on the vertical stabilizer. This is the tail number, but relying on the tail is a procedural error in a high-energy impact scenario. The vertical stabilizer is a lightweight structure. It is often the first component to detach during a breakup and the first to corrode in a jungle environment. When the survey team arrives at the site reported to be inland from Milam, the tail section is not a viable source of proof. It is shattered and scattered. To prove identity without the tail, the team relies on something simpler and more durable than paint on the skin. Internal stenciling, wartime production, and maintenance practices often left identifying marks on protected interior surfaces, where weather and sunlight could not reach. On this wreck, those marks can survive inside engine cowlings, removable panels, and structural bulkheads. This technique changes the survey design. The team does not look for the skin of the aircraft, which has been exposed to 80 years of ultraviolet light and rain. They look for the protected interior surfaces of the mechanical components. The industrial bulldozer that disrupted the site provided an accidental advantage here. By plowing through the crash zone, it flipped the heavy radial engines out of the soil and exposed their inner geometries. The team focuses on the engine cowlings. These are the curved aluminum panels that wrap around the cylinder heads to direct cooling air. There are 3 visible cowlings at the site. The investigators examine the inner face of the aluminum, specifically the area protected by the rocker arm assembly covers. That small interface becomes the difference between guesswork and proof. The rocker arm covers create a tight physical seal against the cowling. For 8 decades, that seal kept water, dirt, and sunlight off the paint underneath. It formed a microenvironment where the binder in the stencil ink could survive. When the team cleans the mud from the interior of the cowling ring, the evidence is clear. The yellow stencil reads AC41-24427. The prefix AC is commonly read as Air Corps, a wartime serial prefix that appears on some markings from that era. This confirms the production vintage. The number 41-24427 corresponds directly to the B-17F flown by Captain Robert L. Williams and his crew. This is a hard data match. It eliminates the possibility that this wreck belongs to any other missing aircraft in the 5th Air Force inventory. The stenciling connects the physical debris on the mountain to the historical loss record in the archives. The airframe identification is decisive. The team does not need to excavate the cockpit or sift for dog tags to know which machine this is. But naming the aircraft is not the same as accounting for the men. We have a number, we have a name. But now we must confirm if the jagged metal edges we see are from the crash itself, or if the bulldozer destroyed the context required to understand the end of the flight. The most dangerous factor in a forensic survey is not the terrain or the weather. It is the risk of misinterpretation, because this debris field has been hit twice, once in 1942 and again by a bulldozer in April 2023. To build an accurate history of the loss, the investigators must separate these two timelines. This requires a strict application of the concept of site contamination. Contamination in this context does not mean chemical pollution. It means the alteration of the physical evidence layout by modern interference. The bulldozer did not just uncover the wreck, it drove over it. It displaced the engines and crushed the fuselage structure. A primary example of this confusion is the propeller assembly. One of the 3 bladed propellers is lying separated from its reduction gear. In a standard crash investigation, a separated propeller can indicate a specific type of engine failure or a structural breakup before impact. But here, the team must look closer at the fracture surface itself. They rely on the chemistry of aluminum to tell time. When aluminum alloy is torn apart, the exposed metal reacts with oxygen. Over 80 years of exposure in a jungle environment, the fracture surface develops a thick, dull gray oxide layer. This is the patina of 1942. However, the survey team observed something different on the propeller shaft. The metal shear is bright, it is shiny silver, it reflects the sunlight. This is a fringe technical detail that acts as a timestamp. A bright fracture surface suggests a comparatively recent break, not one exposed to the weather for decades. This proves that the propeller was attached to the engine when the plane hit the ground and was only torn off recently by the blade of the bulldozer. This fracture analysis allows the team to mentally reconstruct the site before the logging road existed. They can filter out the modern noise. Once the industrial damage is accounted for, the team focuses on the smaller objects scattered in the mud. They locate piles of .50 caliber ammunition. The presence of these rounds confirms the aircraft was armed and ready for combat at the moment of the loss. The brass casings are corroded, but the dimensions are unmistakable. The survey operates under a strict no-removal mandate. The team is permitted to document, map, and photograph, but not to take artifacts or disturb the site. This constraint applies to the hardware, but it is even more critical for the biological evidence. The team photographs specific elements within the debris field that confirm the presence of the 9 crew members. These findings are not disturbed, they are recorded on the map and left in situ. The distinction between the old breaks and the new breaks confirms that the site was intact until the logging crew arrived. The evidence of the crew is still present. The identity is confirmed by the diagnostic stenciling referenced earlier. We have a complete forensic picture. The physical evidence is sorted, but the legal status of the crew remains in limbo. The team has proven who is here, but they cannot yet bring them home. The decision to classify a site as positively identified is not based on probability. It is based on a binary data match. In the context of the B-17F survey, the investigators do not rely on the general shape of wings or the type of engines found in the mud. In this sector of New Britain, that only proves a plane is here, not which one. To cross the threshold from a generic wreck to a specific historical event, the team relies on the alphanumeric code recovered from the cowling. 41-24427 is the pivot point, a binary match to the missing aircrew report filed in September 1942. There is a fringe technical detail in the typography of this stencil that reinforces the conclusion. The letters AC appearing before the serial number stand for Army Corps. This specific font and naming convention was used during a narrow window of production before the United States Army Air Forces standardized the USAAF marking. The presence of the AC prefix aligns perfectly with the manufacturing date of serial number 24427. It confirms that the cowling is original to the airframe and not a replacement part swapped in from a later model depot. This alignment of physical evidence allows the team to select the outcome path. This is a success. The primary objective of the survey was to determine if the debris field uncovered by the logging company was the final resting place of Captain Robert L. Williams and his 8 crew members. The data answers this question with high confidence. The identification removes the ambiguity that has surrounded this loss for 80 years. It converts the site from a geological curiosity into a verified location on the Defense POWMIA Accounting Agency master map. The team is no longer inferring. The diagnostic stenciling referenced earlier and the separation of bulldozer damage from crash damage create a solid chain of evidence. However, this success creates a new immediate constraint. Now that the identity is known, the value of the site changes. It is no longer just scrap metal obstructing a logging road. It is the verified location of 9 American service members. This status shift forces a change in how the site is managed. The logging company can no longer treat the area as a construction zone. The identification acts as a stop work order for the immediate vicinity. The survey has achieved its technical goal. The identity is locked, but the site is still exposed on the edge of a logging road. The next challenge is not engineering. It is stewardship, defining a war grave boundary so what has been found is not lost again. The debris field of the B-17F covers a slope of approximately 300 feet. In the eyes of a surveyor, this geometry defines the scatter of aluminum and steel. But in the eyes of international law, this geometry defines a protected boundary. The identification of serial number 41-24427 changes what this place is. It is no longer just wreckage in the path of a logging road. It is a potential war grave, and it demands coordination between the host nation, local authorities, and the Defense POWMIA Accounting Agency. That coordination can lead to restricted access and a pause in disturbance around the debris field, but it is not an automatic switch. It is a negotiation backed by records, permissions, and responsibility. The coordinates are now flagged. If the bulldozer returns, it risks destroying evidence that both governments may later need. The legacy of this survey is not the recovery of a machine. The aluminum is too corroded to be saved. The legacy is the resolution of the gap in the historical record. The family of the pilot and the 8 crew members have been notified that the location of their loss is no longer a mystery. The map has been updated. The uncertainty that began on September 15, 1942 has ended. The operation concludes with the site secured, but the men still in place. The jungle will keep reclaiming what remains, but the occlusion boundary has been broken. The identity is absolute now. This is no longer a snag in a logging road. It is a verified coordinate where 9 Americans wait for the final leg of their journey home.